Okay, today I would like to share something for the statistic. Okay, for the statistic, and then today my topic is about regression. Any of you know about regression? You don't know? How many of you expert, not expert, or maybe up to 10, maybe 5/10 for SPSS? Can you raise your hand? You don't know about SPSS? Oh, not 50%. The first time. How many of you know about the how to compute mean, how to get standard deviation, how to code? You know what that? This is basic skill for the SPSS. Suppose know about the SPSS. Basic skill is entering that. For sure, define the variables and then input data. Then the most important for you to know how to compute, how to recode. That is the basic skill for SPSS. You don't know about the recode, compute. Because is the process, analysis part. Okay, that means before analysis, you should know what to do with your data. Okay, first of all, I'd like to introduce myself. My name is Megat Aman. Sorry, many of you maybe don't know me because I never teach you, except Zulian. She's my student. Okay, so for SPSS, when we install SPSS, how many of you have a SPSS installer inside your computer? No. Okay, for your information, you can get SPSS software from my UTM. Go to the software center, and then install the SPSS. But make sure during installation, you connect to Wi-Fi inside UTM. But for the outside student, maybe they can use a VPN. Okay, connect to VPN first. And then after you download, you install, make sure you connect to VPN. Each time you want to use, you must connect to VPN. Because this is server-like. Okay, they are require you. If you just open without VPN, you cannot get anything. Just blank software. Okay, make sure you, after install, and then want to use SPSS, you connect to VPN, and then you open SPSS. Not open SPSS, no. You must connect to us and then open SPSS. Okay, if you open SPSS and then connect, I think there is a problem. So make sure you open VPN first, connect to VPN. Okay. This part today I will introduce, or I would like to with you about the multiple regression. What is a multiple regression? Actually, I'm not sure before this. This is first time you use. Maybe you don't know anything about the SPSS. You don't know how to enter data. You don't know how to recode. You don't know how to compute. That is the basic skill to know about that. Okay, for example, if you have a liquid skill, okay, the mean. Okay, that is the manual. That is the manual. Inside the SPSS, you do. You just analyze and get the mean, am I right? Okay, that is okay. And then after that, how you want to compute? You want to get the mean from, for example, question 1, question 2, question 3, question. Your questionnaire, you have a lot of questions, am I right? Okay, you have maybe 20 questions. For example, the first construct, question 1 until question 10. That is, for example, that is first construct. And the second construct, maybe from 11 to 20. You have to construct inside your questionnaire. So how you want to get the mean for the question 1 until question 10? You don't know about. Okay, that is the basic skill. But it's okay. I will go through this one first. Okay, I will go through this one first, and then I will show you what is the regression. What is the regression? After that, maybe I have some data inside the Google Drive. You can open Google Drive. I have a Excel there. After this, I will show you how to use multiple regression, and maybe if you want to know about the standard deviation, you want to know about how to find the mean, so I will show you. Okay. Actually, what is the regression? You know about the correlation? Most of you study about the correlation. You want to know about the correlation between A and B, between satisfaction and achievement, for example. So that is a correlation. Okay, you want to know. That means your finding or your result significant or not, the correlation. Okay, you get 0.5, 0.6, 0.7. Is there any correlation 1.2? No. Correlation is 1. Okay, correlation minimum is 1. More than 1. 0 to 1. Plus minus. That means negative 1 to 1. A negative 1 mean negative 1, negative 1.0, and then negative 0.9, negative 0.1 until 0, and then 0.1, 0.2, 1. It's perfect correlation. Negative 1. Also a perfect correlation, but negative side. Okay, but negative side. You say if they are satisfied, the result will be good. That is positive. 1.0, for example. Or maybe if they are satisfied, the result is good. That is negative. Okay, negative and positive correlation. Okay, I will show you after this. Then, if you know the correlation only relationship between two variables. Okay. Expand to the correlation. Actually, we have regression. What is the regression? This is correlation actually. This is correlation. For example, this is SAT score versus grade point. Okay, Paxi X and Paxi Y. Okay, no problem. This is X, this is Y. So, for example, if you see this code, for example, 460 and maybe 1.4, 1.3. That is correlation. You point. For example, this is a satisfaction, this is score. Okay, you make it a point, and then from this point, you create the correlation. This is the correlation. Normally, the SPSS will plot for you. You enter the data. After you enter the data, SPSS automatically will create for you this line. We call it, this is regression line. Okay, this is correlation. Actually, for correlation, you will get the result R equal, maybe this one is 0.6, for example. This is correlation. Okay, now we want to know about the regression. This is regression actually. What is the formula for this one? Kalau sekolah dulu kita panggil persamaan linear. Sama, y equal mx plus c. Okay, y mx plus c. This is the linear regression. Okay, linear regression. Okay, I will show you. This is easy for you, I think, because if you know the correlation, you will know the regression. Okay, I said Pearson correlation. Pearson, actually we have two, Pearson and Spearman. You don't know about the Spearman? Can you have a, do you know the difference between Spearman and Pearson? There is a lot of statistics you should know. Actually, Spearman and Pearson is also the correlation, but Pearson is for parametric. Spearman is for non-parametric. Okay. Actually, both we can use. If your data normal, you use Pearson. But if your data is not normal, you use Spearman. Okay. You know how to get the normality? You want to know your data normal or not? No. This is basic class for SPSS. But it's okay. I will go through this one first, and then I will show you step by step, basic step for the SPSS. Okay. So Spearman or Pearson correlation, normally they only give you the degree or the strength of the relationship. Okay, is it positive or negative? How strong the correlation? I don't know how strong because depend on the literature. Some literature said if you get 0.3 and above, very strong. Depend on your literature. I don't know. Depend on your book you read. What is the reference you use? While you write in the thesis, you should put the references. Okay. Normally, if they said you get 0.4, 0.3, that is good. Depend on the literature. Normally, we'll get 0.0 until 1.0. Okay, that is correlation. Okay, correlation only the degree. But if you want to create the model, you should have equation. That means you should have some equation, y equals something. Okay, what is mean by y? What is mean by x? I will explain after this. Okay, this is example. Okay, basic for the linear regression. This is we use one dependent and one independent. For example, you want to study about the satisfaction and achievement. For example, there's two variables only. Am I right? Which one is dependent? Which one is independent? Achievement and satisfaction. Depend on your study. Sometimes you say achievement is the result that is dependent based on the satisfaction. Okay, so let's say dependent is the achievement and then independent is the satisfaction. So what do you mean dependent here? Dependent. Okay, we create the model y equal bx plus a. What is the b? What is the a? Okay, step you should know which one is independent. Depend on your framework. You develop the framework, you have an input, you have a process, and then you have an output. Am I right? Normally you have an input, process, and output. You know which one is input, which one is output. Or you don't know. I think you know about the framework. Okay. And normally when you design the framework, you will categorize. This one is input. For example, if you want to study about the achievement, maybe you study about the IQ. You study about the background of the student. Maybe about the family income. Maybe about the achievement before. And then the achievement is the output. Okay. Output means dependent here. Why? Why? Bx plus a. Bx plus a. B actually constant. Okay, if you run analysis using SPSS, you will get the B values and A values. I will show you which one is A, which one is B. Okay, which one is A, which one is B. This is the best concept of the linear regression. Okay, the only one dependent and one independent only. Here, this is one dependent and one independent. How about if you have two independent? For example, achievement, you will have a good achievement if you have a good in terms of satisfaction, in terms of IQ, family income, in terms of previous achievement, for example. You have 4 independent. So you will change here. Y still Y, and then the formula change. Okay, I will show you. This is linear regression. Most of you, I think you are doing a multiple regression, not linear regression. Linear regression means one dependent and one independent. Is it your research one independent? I don't think so. More than that. Okay, you have one dependent and more independent. So we call it multiple regression. The basic concept is y equal bx plus a. Okay. Okay, this is an example. Okay. When you do the linear regression, you will have a straight line here. Okay. This is your data. Okay, this is your data. Okay, this is example of data. And then you will get this one, y equal x plus 4. Why? that is your dependent, and then X independent, and then 4 is the constant. Okay, how you want to get 4? I will do it in SPSS after this. How about BA? BA plus 4. B, is it B here? There is no, because 1x. 1x plus 4 actually. Okay, this is your data. Normally for the regression and correlation, you should know about the R. R means correlation value. Before this, I said correlation value is from negative 0.0 until plus 1.0. That means 0 to 1 plus and to the minus. Okay. 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 Correlation start from 0. Okay. This is 1 plus 1.0 minus 1.00. Okay. This is the correlation. This is what we call R. Okay. This is R. Okay. Another value you should know after this, when you use correlation and regression, is R square. That means R times R. Okay. What is R square? Okay. Okay, here, is it any different? This data, this line, and this line. What is different? Can you see? On the line. This one? Far from the line. Okay. R square means, this is easy way I want to discuss about R square. R square actually is the how fit your model. Okay. If you read SPSS after this, you will get the value of R. You know R? R means correlation. And then the second one is R square. R square means how fit your data. You see this data fit in the line. Am I right? So this one, not fit to the line. Okay. The value here we define by R square. For example, R square you get 0.45. For example, 0.45 means 45%. 45% of your data with the line, on the line. Okay, how fit you get. That means if you create the model after this, you get only 0.01. What it means? 0.01. Only 1% fit. Your data fit to the model. Actually, that is not strong actually. Okay. Your data, you collect the data, and then the data is not fit to the line you do. Okay. So that is not good, I think. So you must find the literature. How about R square? To get the established model or to get the good equation, how many percent or how the value of R square you must get. Okay. So this is R square. This is normally, if you run SPSS, you will get these two values. You should know this. Okay, R and R square. Okay. So this is equation y equal x plus 4. This is also y equal x plus 4. Both of them is same line, but the data is different. That is the description about that R square. Okay, multiple regression. Actually, multiple regression, same as simple regression, but the X is more than 1. For example, before this, you get one dependent, and then you get AX plus B. So this is one dependent and one independent. So now you get more than that. So your equation will be y equal A1 x1 plus A2 x2 plus blah 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 until B. Depend on your independent. How many independent you have? For example, you have 1 independent, 2 independent, 3 independent. So you have 3 independent, 1 dependent. So depend on your research. I don't know about your research. Maybe you have 2 independent, 3 independent. I think most of you get more than 2. At least 3 you have. So your equation will be A1 x1 plus A2 x2 plus A3 x3 plus P. Okay, that is the equation. That means this is your model. Okay, this is your model. Okay, after this, when we run SPSS, I will show you, is it significant or not for X here? Is it significant or not for X2? Is it significant for X3? Is it significant for B? So we'll get this result inside the SPSS during running the SPSS. That is the basic concept of multiple regression. So the aim of your research, you must get this equation. That is the model. Okay. What do you want to do with this model? You can predict something. If you give the equation to others, for example, they can predict something. Okay. For example, I have linear regression. For example, I said achievement equal 0.4 IQ plus 25, for example. This is example of linear regression, the result of the multiple linear regression. So you can use this one to predict something. For example, if you have data, you have some IQ, some data about the IQ, you can predict the achievement. That is the purpose of the regression. Okay, this is the purpose of regression. You want to predict something, use this equation. Use this equation, you can predict something. For example, if you have IQ, you can predict IQ equal 100, for example. 100 times 0.4 plus 25. So you will get the achievement. Now, this is the purpose of multiple regression, to predict something. Okay, to predict something. You have the independent variables. You have a value for independent variables. You put inside the equation, you will get the dependent variables. So if someone said, what is the, why you use this equation? You say you want to predict something. Okay, you want to predict something. Okay, clear this one. This is the basic concept of the correlation and regression. Okay. Normally for inside this student, I put x1, x2 is the independent variable. Just name x1. What is the x1? This is the independent variables. Okay. Okay, this is an example. Okay, this is an example. You have an academic performance, you have an IQ, you have a test, for example. So maybe they cross together. For example, they intercept each other. For example, 20% of B. B here consists of academic achievement, IQ, and then SAT. Okay. So this is the real, what do you call it? The real research. You cannot expect only one factor affect your achievement, for example. There is a lot of factor. Some of the factor maybe they intercept each other. Okay. Okay. Okay, this is an example of the B1, X1, B2, X2 plus A. Yeah, I already mentioned about this. Okay, can you open the SPSS? Can you open the SPSS? You know how to open SPSS? Okay. I give you the data, but data using Microsoft Access. Where is the Microsoft? Where is the data? You download the data. Sorry. Here inside the chat, I already I already share about the data. You can use the same data. Why? If you use your data, maybe you cannot find the same result. You don't know how to read. So I'll give you the data. Okay. This is exercise. Okay. I have data 1, data 2, data 3, and data 4. Okay. The first step, I want you to, what do you call it? Import this data to SPSS. You know how to import? This is first time you use or you already use? Yeah, I think that is the basic knowledge about the SPSS. You open your SPSS. Okay, you open your SPSS and then you import data, or you open Excel just now. Okay, you download and then you open. Okay. Okay. Can you open data 4? Data 4. So I have data here. Customer satisfaction, age, income, spending, and then hours online. You get this one? Can you open this one? Julian, okay. Can you open the data? Okay, maybe you can use the PC here. Okay, can you download and then open this one? I just want to show you how to run multiple regression. Okay, how to run multiple regression, because this is a lesson for today. But after this, I will show you, if you don't know how to compute, how do you know how to export, import, and everything. Okay. Okay. So you have 1, 2, 3, 4, 5. You have 5 variables here. First one is customer satisfaction. Second one is age. Third one is income. Fourth is spending, and then the final one is our online. Okay. Okay. After this, I will show you from the Likert scale how you to produce this one. Okay. Make sure you download my samples. Okay. Question: how much you should have if to run regression? How many data you should have? You know how many data you should have? Minimum data. For your research, for example, how many respondents for your experimental design normally? For experimental, most of you, I think, do this experimental, am I right? Or survey? Most of you quasi-experimental, fully experimental, am I right? Okay. Normally, if you want to run a parametric, you need at least 30 minimum. Some of the literature say you need 25, depend on you. Okay. But some of them say minimum is 30. Minimum is 0. You need minimum of 30 data. Okay, for example, here I have 20, sorry, I have, okay, I have 50 data, 50. I have 50 data. Okay. This is a record for our SPSS. If you see the number here, that means there is one respondent, according to one respondent. Okay, that means if you do the research, at least you need 30 respondents. Okay, better you get more. But if we have a minimum is 30 or 25. I mean, some of the research you can get only 25 is okay to run parametric. Okay. When you during you use SPSS, make sure you know the definition. You know the definition here. Data view. You import from the Excel, you import from CSV, or you import from the Access. Make sure the correct definition for each data. For example, this one. You see this one first. Okay. Customer satisfaction. I declare as a scale. You know scale? You know, is it any different scale, nominal, ordinal? I think you know, eh? Okay. Normally, for the parametric, they come from scale. Okay. So, customer satisfaction scale, and then age is scale, income is scale, spending is scale. Hours online, is it nominal? Suppose scale, I think. The real data supposed to be scaled here. So make sure you change the definition here. This is scale. Because hours, you can count hours. 1 hour, 2 hours, 3 hours, 4 hours, 1.5 hours. Okay. Okay. So this is okay here. Okay here. So we can start running SPSS. Okay. Okay. Let's say I want to run linear regression first. Okay. Just one dependent and one independent. I want to show you how we want to run only one dependent and one independent. Okay, let's say our customer satisfaction is dependent. Let's say I don't know the research, real research. In here, for example, I assume here customer satisfaction or customer satisfaction. Pardon? Yeah. Oh, I not share the screen. Yeah, sorry. Okay, sorry. Sorry, I forgot to share the screen. Okay. Here I have 5 variables. Okay. Let's say customer satisfaction index is dependent. And then income. For example, income as independent. How I want to create linear regression. That means here is customer satisfaction equal income times A plus B. Okay. So you go to regression. Okay, regression. Okay. Okay, you go to linear regression. Here we have a lot of menus for regression actually. Okay, normally for the parametric we use linear regression, and then for non-parametric we use kernel-rich regression. Okay, so I want to show parametric only here. Okay. Okay, you must know the dependent and you must know the independent. Okay, which one is independent? Which one is dependent? That is your research you should know. Before this I said customer satisfaction is dependent and then income is independent. Okay, so I run the first one here and then I put income as a independent. Okay. Okay. Anything you want to set? No. That is basic. Leave it to SPSS, set the default option. There is nothing to set because normally we put the 0.5, okay, 0.05, and it's okay. Just click dependent customer satisfaction and then independent click income. This is linear regression, for example. So the most important part for the SPSS is how to read the data, how to read the result. You click anything, they will produce for you. That is the funny of SPSS. You click whatever you want to click, they will give the result. But you don't know how to read the result. The most important part here is the model summary. And then the second one is ANOVA. The third one is coefficient. Okay, this is 3 important tables you should add inside your thesis. Okay, the first one, model summary. Just now I said R, you know what you mean R there? R 0.803 means correlation, very high correlation, 0.8 R square. Yes, how fit your model? That means 0.644, that means 64.4% of your data near the line, okay? Or on the line we create, okay? And then estimated, adjust a square. This is okay. No need to present inside your research, inside your writing. You just put R and R square. That is the figure you should write inside your thesis. Okay, the first one is okay, table 1. Table 2, ANOVA. ANOVA, you know what you mean ANOVA? Analysis of variance. Analysis of variance. So this model, if you see here, value is less than 0.01. Normally for education, we set 0.5 for comparison. Why we should see, why we set 0.5? 0.05, sorry, 0.05. Because we are not critical. If you use medicine, for example, you use 0.001, for example. That is the percent we accept. We only accept 5%. Now we said 0.05 means we accept error only 5%. Okay? 0.05. Normally, this is the number for the education. If you use a medical, maybe you use 0.001 or 0.01. Only 1%. Okay, only 1%. Okay, that means if you run the data, you accept 5% error. That is the simple word. You only accept 5% error. Okay, so this one, if you see this one, the value is 0.001. Okay, significant or not? You compare 0.001, 0.05. Which one is bigger? Which one is less? Okay, so this is significant. Okay, this is significant because this value is less than 0.05. Apa pening lagi ni? You know how to decide 0.05? This is the important part for you to know. Because during writing, you should explain about the significance. Okay? Normally, we said just now for education, we accept 5% error. 5% error means 0.05. Okay? You compare the value here. You compare the value here. If you get the value is less than 0.05, that means significant. Okay? If you get more than 0.05, that is not significant. Okay? Clear? You must remember the term, the item. If you want to know the significant value, you should compare significant value with the value you get from from your standard. For example, your standard for education, you said 0.05 or 5% error. So here you get 0.01. So 0.01 is less than 0.05. That means significant. Okay. That is the second table you should know. You want to know about the DF, mean square? I think it's okay. Let's just leave it. For your information, DF is degree of freedom. You have two variables, am I right? Y and X. one dependent, one independent. So df means n minus 1. You have 2, that means 2 minus 1 to be 1. So df is one, here is 1. It's okay. How about the df here? How about the df here? This is the calculation of the data. How many data have? 50. So 50 minus 1 is 49. Okay. For the residual, normally they n minus 1 because there is 2 variables. Okay, this is okay. Just leave it. What you should know here, only significant value. Okay. Okay, the third one. This is your model. Can you see here? Model 1, constant B 3.983. Standard error, that's okay. No need to read this one. And then the significant value. Income 0.01. And then the significant value less than 0.01. So what is your equation actually? What is your result? How to read the result? How to write the result? Okay. So you said just now we have y equal ax plus b because you run only 2 variables, dependent and one independent variables. What is the y here? Y here is the customer satisfaction, am I right? Customer satisfaction equal ax. X mean what? Income. Okay. You see here income. Income constant here is 0.001. That means your equation will be 0.001 income plus constant 3.9. 3.983. This is your result. This is your model. Okay, this is your model. That means you can predict the customer satisfaction based on the income. Okay, for example, if you get income 2,000, so you know 2,000 times 0.01 plus 3 point something, you get customer satisfaction. And this is the result for our model. This is our model. You can write this one, contribution of the PhD or Masters. Okay, that means you produce some formula. You produce some formula to know the customer satisfaction based on the income. Okay, can you run customer satisfaction equal x1, x2, x3 just now? Let me check again. I forgot about the okay, income, spending, and then our online. Okay. Okay. So I put independent now 3: income, spending, and hour. 3. Yeah. That means your formula, your equation will be customer satisfaction equal income A plus spending A2 plus our online's A3 plus B. Okay, so you will get this formula by using this one. Okay. Okay, this is an SPSS regression. Okay. Okay, here you will get the model summary. You will get R square. You will get the R here. Okay. You will get the R and R square. Same before this. And then you will get the ANOVA table here. Okay, no problem. And then from here, can you create your equation? Okay, can you see here? Less 0.01, 0.29, 0.01, 0.008. Is there any difference from the 3 variable here. 1, 2, 3. Is it different? This is significant. This is significant. How about this one? Not significant. Because 2.9. Sorry, 0.29. More than 0.5. More than 0.05. Apa maksudnya? What does it mean? That means income is not too significant. Yes. If you put inside the equation, that is okay, but that is not too significant for the income. Okay? So the most significant is this one, spending and hours online, because this is significant variables. No, we don't say like that. We just compare between 0.05. So we said both of these variables will be significant. We cannot compare which one is more effect now. Okay? So we said spending and our online is significant in this equation. Okay? So you have equation now. You have customer satisfaction equal 0.00 spending. You see, variable here is 0. That's why that is not significant. Some 0 times something, so for sure you will get 0. That's why there is not significant. Okay. So if you put 0.00 income, nothing, nothing. That means if you get more than salary, it's okay, but there is nothing, no effect to customer satisfaction. Okay. Okay. The second one plus 0.02 spending plus 296 hours online. Okay. If you want to say which one is more significant, you follow this one. Okay? Because this is bigger, am I right? Rather than this one. So this one is more effect. Okay. But inside the writing, said both of them, spending and hours online is significant. Okay. So you can write the value of your equation. That's all for modeling. That means you can write inside your thesis, this is my contribution, this is model I get. Okay? There is no graph, there is no chart for the regression actually. Okay? So maybe someone said, is it fit your model? Is it good your model? Based on R square. Okay? You get 77.2%. Okay? How about if you get 0.5% only or 5% only? Find the literature. I don't know. It's on the literature. Is it they accept or not? R square is 0.05. Normally for the regression, we only focus on equation. Okay, we focus on this equation. Okay. Clear? You know how to run a regression now? Okay, this is from my data. How about the real data for the Likert scale, for example? Can you open the Likert scale data? Forgot which one. Okay, try to open data from Likert scale. I think Likert scale. Okay, data 2. Can you open data 2? Okay. This is data 2. I'll give you 4 data, I think. 4 data. From online, is there any question you can ask me? Okay. You see this data? That means you have a Likert scale or you have a questionnaire. Maximum score is 1 to 4. Am I right? Is there any 5? No. 1 to 4. Okay. from question 1 until question 12. Okay? Can you analyze this one? First, can you create another variable called mean inside this data? You know how to create mean? Zulian, okay? You okay? Okay. Okay. Sorry, I have 14 data. Okay, let's say inside this questionnaire, I have 14 questions. I have 3 construct. You know construct? For example, customer satisfaction. For example, this is customer satisfaction. Okay, inside the customer satisfaction, maybe I focus first on facilities, for example. Facility Q1 until Q7, for example. This is construct for the facility. The second one, quality. Okay, maybe quality of service, maybe Q7 until Q11, for example. And then I have another construct, for example, others. I don't know others. What is others actually? Okay, from Q12 until Q14. Okay. Can you have a mean for this construct? Okay. There is 2 school of thought actually. One of them said you can analyze or you can compute this ordinal data. The second one, maybe they can accept you. You can compute this one. Depend on you. Depend on your supervisor talk. Okay? I don't know. Depend on your supervisor. Maybe some of the supervisors said, you cannot compute this one. You just have a percentage is enough. So depend on you. Okay? Depend on your supervisor and your examiner actually. Okay? During my PhD, I have some problem with this one. The examiner said, why you compute ordinal data? Okay? During PhD, I do it using online, and then the skill for the Likert they can adjust. Okay, so you must find some evidence from the researcher. They said ordinal data from Likert also can have a mean. You must find that one. But I will show you. Most of the lecturers, most of the assessor, they accept. Okay, normally if you said you want to know the level of satisfaction, what do you expect your result? For example, this is the Likert scale. You give the questionnaire. Okay. After that, inside the objective, you said you want to find the level of customer satisfaction. What do you want to do? You understand what I mean? Tak sampai. You have objective, am I right? Okay. You do the questionnaire, and then the questionnaire consists of 14 questions. Okay. Inside the objective, you want to find out the level of customer satisfaction. Level of customer satisfaction. For example, you want to know, is it high or low or moderate? So what you want to do? How you want to analyze this data to get the result for your objective? You must know that if you do the research objective, you must answer the objective. Okay, for example, inside your research, you said you want to develop model for customer satisfaction. So this is your answer. Okay, this is the model. Okay, just now I said, how about the level? Level of satisfaction. You want to find out the level of satisfaction. How you do if you get this data? And this is the basic training about the SPSS actually. For regression, that is the after you do some modification, you do some, for example, before this you said our data I have 7.5 customer satisfaction, am I right? This is maybe come from here. Yeah, you want to count the mean. Yeah, how to count the mean from here? There is two mean here. First, mean for each question. That means from the question 1, if you plus 4 plus 3 plus 3 plus 3 plus 4 plus 4 plus 2 plus 3, you divide by the number of the respondent, you'll get the mean. This is the one. Second one, how about the every respondent? That is another mean. Okay, something like this. I want to know the mean of the facility. Facility, for example, I have Q1 until Q7. Okay, I have Q1 until Q7. How about the mean here? And the mean here? Mean here. Okay? So this is the basic thing about the SPSS. Okay? From the row, you get one mean. From the column, you also get the mean. Okay, for example, I give you the easy way to get the mean from the column. For example, Q1, what is the mean for Q1? Okay, if you get the mean for the Q1, the first one, if you have data, make sure your definition is right. Okay, is it right, your definition? Is it nominal, ordinal, scale for the questionnaire? Questionnaire, what is the definition? The right definition for the questionnaire? 1, 2, 3, 4. That is a ordinal. That is order, agreement order, am I right? Likert scale is agreement order. 1, 2, 3, 4. That is the agreement. Agreement means a level of agreement. So that is the ordinal data. Okay, that is ordinal data. So the first step, make sure you use the right definition. So here, this is wrong. Okay, this is wrong. Suppose from the question 1 should be ordinal. Okay, make sure you change this one to ordinal first. How about the gender? Is it right? Gender is nominal. Is it right? Yes. You know about the ordinal, nominal, and scale. That is the 3 types of data. Make sure you can differentiate which one is not, which one is ordinal, which one is scale or interval. Okay. Okay. This is definition. How to fill up this one? You know how to change the level, how to change the value. For example, 1 is less agree. 2 is disagree. 3 is agree. 4 is more agree, for example. Okay, so you know how to put here values, label, everything here. Forgot already. Okay, actually, this is the name is okay. This is the type. For example, if you have number, you should numeric. You put numeric here. But if you have a name, you have a gender, you have a something string. String. What do you mean by string? Character. Inside the keyboard, we have character A to Z. So there is string. You put string. Okay. If you want to calculate, you put number. Numeric. Yeah. And then this is weight. Weight mean how large the space there is okay, just by default. Decimal, how many decimal you want to put. Okay, label. Okay, for strongly agree, disagree, here. Value. Okay, here is the label. For example, Q1. What is Q1? The question. the question. For example, question 1, I like to play football. So you put it inside the label. Your questionnaire. But for me, I suggest you never put here. Because when you do some analysis, you need some space. You don't want the full questionnaire there. You just put Q1, Q2, Q3, and then during writing, you put Q1 is the full question. I like to play football. Okay, no need to put here. But if you want to put, it's okay, no problem. Okay. You said just now, strongly agree, disagree. So you put here. For example, for the value here, Q1, for example, Q1, level here. Okay. So you put the label here. Okay. 1. What do you mean by 1? Disagree. Strongly disagree. Okay, strongly disagree. Okay. 2, disagree. And then 3 means agree. I put A only. Okay, 4, strongly agree. For example, this is example. Okay, so this is the value. This is the value for the 1, 2, 3, 4. Okay, you already have done, you done 1, you can copy paste because this is same. Copy, example, I put here, I paste here, sorry, paste. Okay. Okay, so settle for the definition actually. Okay, make sure you know how to define your variables. The most important part for you, if you do the research, first you want to transform your questionnaire or your finding to the SPSS. So you must know how to define that by using. Okay. Okay. After that, you already have a value here. You go back to your data. You see, this is your data. Okay. You want to know the agreement of the Q1, for example. How many said agree? How many people said disagree? So for example, for the Q1 first, I want to show you how the result. Okay, you go to the analyze. Okay, analyze, descriptive statistic, and then normally you can have a frequency. Okay, for the frequency, for example, you want to know about the question 1 to until question 14. You just drag. What kind of statistic you want? You want the mean and then standard deviation, for example. Depend on you. What do you want to analyze? I don't know. This is the example. Most of the students, when they do Likert scale, they want to mean. Maybe you want to analyze medium. It's okay. You want to analyze smooth. Depend on you. What you expect from your questionnaire? What you get? What you want to get? You want to get the mean? You want to get the mode? You want to get the medium? Depend on you. So, for example, now I want to have a result for the mean and standard deviation. This is an example. Okay. So that is okay here. Continue. Okay. You want to show the chart? But, for me, for my experience, better you do inside the Excel for the chart because it's quite beautiful rather than inside the SPSS. Depend on you. If you want to say you want to do the chart, it's okay. But for me, for my experience, better you do inside the Excel. Excel lagi cantik lah. More beautiful. More beautiful rather than SPSS because SPSS only tools. You get the figure and then you put inside the Excel, right? Okay. No need to change anything here. You just click OK, and then you will get the result. See? This is the result, all the result. Okay, you must know how to read. For example, Q1, they have 359 respondent. Missing value? No missing value. Mean for question number 1 is 3.1. See? This is mean for question number 1. Okay, this is standard deviation. But you must know, whatever you do, you must know the meaning. For example, I said here standard deviation. What do you mean by standard deviation here? Mean, maybe you know average. What is the standard deviation? Why you put the standard deviation? Oh, yeah. How data spread. Okay. For example, if you have mean 3.11, that means 0.7 above and 0.7 below. That is the range for this data. That means if you get smaller, it's better than you get larger. We are accept if you get maybe 1.2 for standard deviation, but if you get 3. For example, you get mean 3.1, but standard deviation you get 3.0. Wow, that means your range is very far away. Okay, better you get for this one. If you get smaller, it's better, I think. Okay, okay, there is. And then this is the, what do you call it? Why they have a 0 there? Oh, that means they have value 0, start 0, not starting from the 1. Just now I said the value 1 is SA. Suppose they have 1. Because this data normally I collect from the website. Normally if you put inside the Excel, by default is 0. Okay, suppose what you should do. Missing value. Suppose inside the definition you, okay, let me teach you. Let me show you how to set this one here. Okay, sorry, data view. This is the definition view. Sorry. Okay, here missing value. Okay, you just put missing value here. Example 0. So if you have 0 here, that means, sorry. Depend on you because your question. Okay, now I set the 0 is missing value and I try run again. Frequency. And then when I click OK, see, there is no 0 anymore. Okay. And then here they have a missing value. See? What do you know what is missing value? You know what is the missing value here? No response from our respondent. Okay. 1, 2, 3, 4. They put together. 1, 2, 3, 4. Okay. So this is the missing value. So now we get SD, D, A, and SA here. Okay. Clear here? This is one of the from the item. Okay, to get this one. Okay. Okay, we have 10 minutes more because we have a class, I think. Okay, how to get facilities mean? You want to know the facilities. This is the construct, facilities, quality, and the others, for example. Facility, question 1 until question 7, you want to know the mean. That means inside the SPSS, you will have another data here. Okay, you will have mean here. Okay, I'll show you. Okay, okay, you go to the transform and then you pick record in different variables. Record in different variables. Okay, record in different variables. Okay, you want to know the mean, am I right? Oh, sorry. I don't want to use record. I want to use compute. Where is the compute? Compute. Mana dia? Ah, ni atas sekali, Allah. Okay, compute variables. Sorry. I want to compute variables. Not the record. Record means you want to transform something. For example, you have 4. 1, 2, 3, 4. You want to record become 1 and 2, for example. 1 and 2 become 1. 3 and 4 become 2, for example. You want to record. So we use record. This is compute. So the easy way you want to do is you just put the variable name here. For example, mean facility. Okay. Facility. Okay, mean facility. Okay. You put the variable name first. And then you find from here mean. Okay. Sama macam Excel. Same with the Excel. You find the mean, MEAN. Here. You select all and then from here you choose all and then you okay, double click here. Okay, see the figure question mark. If of the question mark you change with the variable names. For example, Q1, Q2 until Q7. Double click. Or you may type or you this is the way you do. Okay. Mean Q1 until Q7. If you have quality, so you put the mean quality Q7 until Q11. And then if you have others, mean others, Q12 until Q14. Okay, I show you. This is the mean facilities. So just press OK. You will get the result here. See? Okay, this is the mean for first one, facility. Second one is quality, and then your third one is others. Okay, so this is the how you process data actually. Before this, I show you we have this one. Am I right? This is maybe come from the mean of the every construct. Okay, this is mean from every construct, or maybe spending hours. Spending hours. Maybe you count from this one, from the forum, plus online, synchronized, and then plus chatting. So you count here. So that is the process. Same like compute here. Compute, you find mean before this. You can also plus, you can also minus, you can also multiply, and do whatever you want. Okay? Okay. So this is the sorry. Okay, this is the mean. Okay, you should know how to manipulate data here. Okay, this is the basic concept. How to use SPSS. If you don't know how to use SPSS, I don't know how you want to get this one. Because this is already finished data actually. You already manipulate, you already count, you already mean, you already plus everything, and then the last action is you do the regression. So this is the basic for the what do you call it? To find mean. Okay, compute. You know how to compute. You know how to recode. Okay, recode means you need to modify your questionnaire. For example, you have 1, 2, 3, 4, 5. And then when you want to 3 is 1. And then you want to recode 4 equal 4, 5 equal 5, for example. So sometimes you need that method. Or maybe you want to know you 4 now. To recode 1 and 2 only. Agree? Disagree? How you want to do? Okay. How you want to do inside the SPSS? Recode, yes. Okay. We call it recode. Okay, for example, here, recode, because this is important part for you, into different variables. For example, Q1 you become Q1 new, for example, new, I said Q1 new here, and then you want to change the value. So if you find value 1, it's become 1. You add. If you find value 2, become 1. Okay, add. If you find 3, become 2. And then if you find 4, there is become 2. This is example how to recode. This is example how to recode. That means if you want to recode your questionnaire, okay, 1 and 2 become 1, 2 and 3 become 2. That means your questionnaire will be yes, no. Agree and disagree, for example. Sometimes you need that method to analyze data. Or maybe you have a salary. You want to put M40, B40, T20. B40, you know, B40? That is the level of financial. Okay, B40, M40, and T20. T20 is very high, more than 10,000. M40 maybe 4,000 to 9,000. And then below 4,000 maybe B40. So you want to record, for example, you have a raw data, and then you must record if you want to do the analysis. You want to know how many people from the V40, how many percent. So you calculate. You must use the record method. Record method. Okay. Anything you want to ask me? 4 o'clock already because you have a class. Okay. See. Here I have Q1, Q2. Yes. Okay. Okay. What is your expected finding for your research? What do you want to do? That means you want to create correlation only. You want to know the correlation, just correlation. You cannot do the multiple regression because this is one dependent. Yes. Yes. Okay. That is correlation study actually because you have two dependents. Okay. Okay. Anything you want to ask me? Okay, I will stop the session. If you don't have a class, you can stay here because the session until 4 o'clock. Because some of them have a class. Okay. Anything from the online? You want to ask something?
Yes, doctor. I need to ask question.
Okay.
I'm PhD student from social sciences.
Okay.
And Actually, my study was mixed method approach. So in that, I have chosen statistical analysis through SPSS.
Okay.
But recently, I'm facing some problems with SPSS. Actually, uh, my examiner says that I'm not good in SPSS, and exactly, it is true because being student of language, it is difficult to handle the numbers. So yeah, the thing is that I just want to know that uh, that I'm just confused that either I should go for it or not. Basically, my study carries 50 items, multiple items, and I just want to explore the statistics of the perceptions of the students. So, is it good for me to go for to choose SPSS, or I should go for Google Forms where I can analyze the data as well? Similarly, I just want to know your suggestions. Because because according to examiners and according to some of the studies, it says that SPS is not for PhD students. Is it true? We should in statistics. And for PhD students, only descriptive statistics is not enough. Is it correct?
No. SPSS is a powerful tools for statistics, actually. We only explore about the mean and media more. This is the descriptive statistic. Actually, inside the SPSS, you have a lot. For example, if you want to know CFA, EFA, you know EFA, CFA, because there is a lot
Uh,
of statistical actually inside the
yeah,
SPSS.
yes.
Only for the
Yeah.
rush, for example, if you want to run rush, the first step you put your data inside the SPSS first, and then from then you export to rush. That is the way use. So that is not correct for me if you said SPSS is not suitable for the PhD students.
No, especially at that time when my study is mixed method. My purpose is not to get expertise on SPSS. My purpose is to get to compare, to explore, to support the qualitative study. For that, I choose SPSS because I thought it's a tool going to help me and go to design my study very nicely. And but then I come to know I have to get expertise on it as well. Now it's very difficult for me to handle this tool because I'm not good in it. So the same thing I observed in the Google form is also giving us some kind of graphs and statistics. So what's your suggestion that it's a risk to go for this SPSS for someone who is very basic into it, or we should I should go for it?
For me, depend on you actually. If you want to know only mean, medium, mode, maybe you can use Excel only. SPSS only tools. Whatever software you use, it's okay. If you want to use calculator, it's okay, no problem. Nobody knows about that. Okay. SPSS only a
Okay.
tool for you to help you to analyze. Maybe you use the mixed method. It's okay. There is no problem with the mixed method. But maybe one of the part you can analyze something. So you can use SPSS or maybe you can use Excel only. It's okay. No problem.
Okay.
Most
Thank you.
what the
Yeah.
result you want. For example, you want to find the mean. So depend on you. Maybe you can find online using mean or you use calculator. Depend on you. Okay.
Okay. Yeah. Thank you.
There's only tools for you.
Yes. Yeah. Yeah. Thank you. Thank you so much.
Okay. Okay, I think I will end the session and then I will give the recording, this recording after the WLP in my WebEx. Okay, that's all. Thank you very much. See you soon.
Okay, thank you, Doctor.
Okay.
Thank you, Abdul.
Okay, thank you.